Hello students, before learning on to capacitance, we must learn about some of the important formulas that we have taken up in our previous videos, and you must refer to the electric field and electric potential to understand what is electric field and electric potential and the relation between them before understanding the capacitance. So I would like you to go those two videos, which are very short videos of approximately 10 to 12 minutes, must refer to that before coming on to this. So for the understanding of this video, I will just re-revise. For the sake of understanding, I am just rewriting the relation between the electric field and the electric potential. Here dV by dr is minus E, or in the integration form we can write as V is equal to minus times integration of, that is, infinity to R E dot dr. The significance of the minus sign is that direction of electric field will be in the direction of decreasing potential. You must remember that, which will help you always to determine the direction of electric field when the equipotential surfaces are given in any question. So now we come on to the capacitance. The capacitance of a conductor may be defined as the charge required to increase the potential by unity. Which, if there is any conductor, it will have the capacity to hold some charge. So when we add a charge to it, there is an increase in the potential. So up to certain potential, it can hold the charge. Beyond that, if we increase the potential, what will happen? Because of the electrostatic forces between the atoms, ionization happens and it cannot hold further charges. Therefore, there is a capacity up to which it can hold the charge. So this is defined as Q is equal to C into V, where C is called as the capacitance of the conductor and V is the voltage which it can acquire. Or we can write C is equal to Q upon V, and the definition is capacitance of a conductor may be defined as the charge required to increase the potential by unity. This you can understand. I can write C is equal to Q upon V, and if V is equal to 1, then C is equal to Q. So this is what the definition of the capacitance says. So the capacitance depends on the several factors. It depends on the size and the shape of the conductor. It depends on the nature of the surrounding medium, and it depends on the presence of the conductors in its neighborhood, because all that affect the charge carrying capacity of the conductor. I will come on to this because the presence of any conductor will help us to increase the capacity of a conductor. We will come on to this. The unit of conductor is coulombs per volt, or we can define it as 1 farad. Now capacitance of an isolated spherical conductor. So now we are talking currently of an isolated. If I talk of a isolated sphere conductor on which a charge q is given. So the charge q will be entirely on its surface. All its charge will be on its surface, and if its radius is r, then the potential is given by 1 upon 4 pi epsilon naught q by r. I am again saying you must refer to my videos on electric potential and electric field, and at the same time you can refer to the Gauss's law also before coming on to this topic, because by understanding and seeing those videos you can understand what I am going to do in this video. So V is equal to 1 upon 4 pi epsilon naught q by r. So Q by V is equal to C as per the definition, which is the capacitance. It is 4 pi epsilon naught into R. Now, after having understood with a simple example of an isolated spherical conductor, I will come on to the concept of a capacitor. You might have all heard of the capacitor. Capacitors are being used widely in the electronic circuits along with the transistors, diodes, triodes. So those capacitors are very important part of any electronic circuits that we use on all our electronic devices. So a capacitor is an arrangement of two conductors which are separated by an insulating medium that is used to store electric charge or electrical energy. Okay, so how will I explain this? Means to understand the principle of the capacitor. If I have an isolated conductor, you can see here plate A, this is an isolated conductor and is positively charged. So the charge is positive, which is entirely lying on its surface. Now if I bring a conductor, new conductor near to it, when we bring a new conductor near to it, what will happen? Because of the positive charge, the surface which is near to it acquires an induced negative charge. And there is a surface which is away from it, because of the induction of the negative charge, it acquires a positive charge, which I have shown here. Now, steps is if a conductor is brought near to the charge conductor, I have written here for the simplicity so that in the video you don't forget what I have told. So induced minus charge develops on the near face and a positive charge develops on the opposite face. Now the negative induced charge tends to reduce the potential because it is a negative charge, it will tend to reduce the potential of the conductor, and the positive charge tends to increase the potential of the conductor. But what happens, since the negative charge is closer to the conductor and a positive charge is away from the conductor, so the net effect is the decrease in the potential of the conductor. Decrease means since capacitance is inversely proportional to the potential, so the presence of the vicinity of a conductor near to it will allow it to store more charges. So this is the principle of the capacitor. This is the principle of the capacitor. A capacitor is an arrangement of two conductors separated by an insulating medium that is used to store electrical charge or electrical energy. So, this is the combination of two conductors whereby bringing a one conductor near to a charge conductor in the vicinity, we increase the capacity of the conductor. And as I have rightly told, the capacitor depends on the presence of the other conductors in the neighborhood. So this is the principle being utilized for the capacitors. Hope you would have understood what is capacitor. So if positive induced charge is grounded, again in this case, if I induce the positive charge, what will happen? The effect of the increase in potential due to the positive induced charge goes away, and this the overall effective potential further reduces of the conductor near to it. So induct the capacitance further increases. The capacitance of an insulated conductor is considerably increased when we placed an earth connected conductor near to it. Such a system of two conductors is called a capacitor. So we called it as a capacitor. Now hope you would have understood what is capacitance and what is capacitor. So now we come to the parallel plate capacitor. Parallel plate capacitor, you can see there are two plates. One is positive charge, one is negative charge, which are separated by a distance d. The area of each conducting plate is A and the charge density is sigma. So for the simplicity of the students, I have made the electric field because of the each plate in the different regions. You can see in between, because of the positive plate, the electric field is defined as sigma upon 2 epsilon naught with the green. With the green, whatever is defined is the electric field because of the positive plate, and because of the negative plate, this is shown with the yellow. So this is shown with the yellow. So with this, you can see that net electric field outside the capacitor is 0, whereas inside it will be sigma upon epsilon. So this, for the understanding, I have done it with the Gaussian surface, how sigma upon epsilon naught comes with the Gauss's law. So you can understand, I have drawn here a Gaussian surface and then use the formula of the Gauss's law to find out the electric field because of the thin conducting plate. Okay. Now We know that the potential difference across the two plates is V, which is given by E into D. Before starting this, I have told you must understand the relation between the electric field and the voltage. So V is nothing but E into D, where D is the separation between the two plates. So substituting V is equal to sigma upon epsilon naught. I have calculated electric field is sigma upon epsilon naught. That value is substituted, but sigma is charge per unit area. Resubstituted, it is Q by A. So after readjustment Q by A, I got epsilon naught A by D. So capacitance of a parallel plate capacitor is given by epsilon naught A by D. So I'll cover the example of a cylindrical capacitor also. Similar way, it is very simple through a Gaussian surface which I have drawn like a yellow cylinder. So E is equal to 2 pi RL into Q upon epsilon naught. E is equal to lambda upon with that. But Q is equal to lambda into L. L is the total length and lambda is the charge per unit length. So total charge will be Q is equal to lambda into L. So I have substituted the value of Q as lambda into L. That has helped me to find out the electric field in between the two spherical conductors. This I have already solved while making my video on electric field. You can refer to that also to understand that. Now after that, using the formula of electric field and the volts, we have calculated the voltage between the two conductors. So this is an integration lambda upon 2 pi epsilon naught r dr. By using the formula of the integration, we have calculated it is log r log e to the base r. So a to b and voltage and v is equal to lambda upon 2 pi epsilon naught r, which is a simple mathematics. You can understand lambda upon 2 pi epsilon naught ln b by a, but lambda is nothing but q by l. So substituting the value as q by l. So q by v, we get 2 pi epsilon naught l into ln of b by a, which helps me to find out the capacitance. So the overall idea of explaining this is you should know this formula, because this formula will help you to find out the voltage between the two conductors, and then by using the formula, by using the electric field between the two conductors and therefore then the voltage, and with this you can find out the capacitance of the particular capacitor, whether it is a spherical capacitor or whether it is a parallel plate capacitor or it is a cylindrical capacitor. You can do it for the spherical capacitor also. Now another thing, we know that V is nothing but minus 0 to R, infinity to R, E dot dr. You see, so here now another thing is, if in between the two conductors, if somehow we can manage the electric field also, if we can make some variation in the electric field, we can reduce the electric field. What will happen? The reduction of the electric field will also reduce the voltage between the conductors and increase the capacitance. So that's why comes the use of the dielectrics. So we will talk about dielectrics and the various and the combinations of equivalent capacitance when they are connected in series and parallel, and many more examples in our next video. Hope you would like this and would have understood the basic principle of capacitance in capacitance. Thank you.